Hi there, AP Precalculus folks. I've seen a lot of folks on this Facebook page talk about wanting hands-on activities where students take real-world data and analyze it. And so I wanted to show you something I developed for Unit 1. And I know that's in the distant past for a lot of us, but if you're watching this video and it's April, maybe you want to do this for review, or maybe you're seeing this video over the summer and you want to do something like this in your Unit 1. So what you'll see here under my document camera here is you'll see this is just a clipboard and it's been turned. So this is now an incline. I created these sheets of paper, but a student could easily just use a ruler and just make marks every centimeter just on a regular piece of paper. And then this is another clipboard. And if you'll look carefully, I'm putting the other clipboard right here. Okay, so what you'll see here is that this end of the clipboard is inclined, and I've got a marble. So now you can roll the marble down. But what's the marble going to do? What the marble is going to do is it's going to roll down one clipboard and roll up the other and then back. Do you see how that works, right? So what I did was I filmed this happening using an app called Physic, F-I-Z-Z-I-Q. And then what you can do is you can import using something called video motion analysis. It's under, hold on a second, it's under motion analysis, video motion analysis, like that there, you see there, okay? And then you can go to your videos and you can load a video like this. And so you set the scale, and then you go, okay, so whatever. Okay, hold on a second. I'm just going to make up something here. Okay, right. All right. So then, okay. So then what you do is you can frame forward the video, frame. Oh, I went too far forward. Okay, so let's see if we can see. There's the marble right there. You can see it right there. So what I did is I took position data every 1/10 of a second. That for me is 6 frames because I did 60 frames a second. So every 6 frames, and it has the number of milliseconds right there. So an even 100 multiple of milliseconds, that's 1 full second right there. And so with that, what I did is I made a table. So what I want my students to find out is this quadratic? Is the x versus time? By the way, this is how I call it. I call t time is the independent variable, and x. So for if you're teaching just pure pre-cal, I teach pre-calculus along with physics. So this would be x for time and y for position. But in physics, we call this t for time and x for position. So the question is x equal to something t squared plus something t plus something? Is it quadratic? So what I did is I took a first order difference just between these that I pulled off of my video. Notice that the times are even intervals. That's critical for this. And then what we're going to do is we're going to do this finite difference here. It's a single layer finite difference, single order finite difference. And then I plotted these on the vertical, and I just didn't leave a scale on the horizontal, right? So if you want to call these delta x's, right, then the delta x's went on the vertical. And then what I noticed is that it made a pretty good line. So if this is linear, which it was, then I can say that this right here is quadratic, right? Now, another thing I could do, and I didn't do it for this video, is just plot x going up and t going sideways, okay? If you look carefully, it will go down and then back up because it goes from 25 to 4 and then back to 22, right? And so we can see that. We could do a quadratic regression using Desmos. But there's a lot of things that we can do with this data where students can analyze the motion, take finite differences, and draw conclusions from those finite differences. I also do something like this, but for a pullback toy car. For a pullback toy car, the position versus time. Notice how I'm doing that. I know it's confusing for a lot of people when x, which is positions on the vertical. So you would just modify this and just say y is position and x is time. You're more than welcome to do that. But for a pullback toy car, the pullback toy car speeds up and then slows down. So then I ask my students to find out, is this a cubic? Because it looks like it could be part of a cubic function. Why can it not be a parabola? Well, the concavity changes, so it can't be a parabola. It has to be at least a cubic or higher, right? So what order is it if we're going to treat it as a polynomial? So these are things that I do to work with students on polynomials, especially with finite differences. And so you're welcome to try it and reach out to me if you are interested, if you have any questions, or if you're interested in more activities like this. Well, if you like this activity, I am wondering if you knew this. You can use things like a golf ball to teach ratio, average, linear equations, things all the way up through geometry, piecewise function, parametric equations, all the way up through infinite series in calculus. Do you know that you could use a soda bottle to teach things as simple as functional dependence at the junior high level, all the way up through related rates, all the way through calculus? What if I told you that you could use a pencil, ruler, and coins in order to do things like geometric scaling or the Pythagorean theorem or linear equations? I forgot to put on here rational functions, right? That you can do ratio and proportional and reciprocal functions and sinusoidal graphs just using a straw and a tuner, or these little pop tubes, right? That you can do quadratic functions and parametric equations with a dart launcher. You can do rational functions and asymptotes, or even teach basic domain and range with a lens and a flashlight, things that you can get at Dollar Tree quite easily. That if you have a water and a thermometer, that you could do exponential decay, that you could teach things as complicated as slope fields and differential equations. These are all things that you can teach at whatever level of math you teach using basic stuff that you can find or buy just from Dollar Tree or from really cheap places. What about games? What about math-based games where you could go from, basic sixth grade adding up rational numbers to games where students are shooting y equals mx plus b lines at each other, or they're shooting inequalities at each other, and there's actual strategy to it, right? What about sinusoidal graph wars, that they shoot sinusoidal graphs at each other, or they punch each other out with complex numbers, or they chase each other with the Pythagorean theorem and things like that? Is this stuff that you would want to do in your math class, playing games and doing hands-on stuff? Would you want to do some performance-based assessments, right? I'm not asking you to get rid of your traditional tests, but something that's more open-ended for students, right? What about integrating little writing pieces into your application problems, right? Your word problems, where students have to write a little bit, not just solve the problem. Is that something that you think would be valuable for your students? Is that something cross-curricular that would make you a leader on your campus? What about, would you like to see some methods of remediating tests and quizzes, right? Things where students are getting not only individual feedback, but individual remediation without you having to sit down in front of every single student. Would you like to integrate some basic computer programming in your math course? If any of this is interesting to you, I think that you ought to come to my Summer Institute for Math Teachers. This summer, it's July 15th through the 18th. I teach physics and math. My forte is teaching physics teachers how to make their classes more hands-on and engaging. I've started doing that for math also. Last year was our first Summer Institute. We had 12 participants. They all thought it was pretty neat, the things that they could do with their students. It was much more engaging and fun and things like that. So if you go to findphysics.com, click on Math 2024 Institute, then you'll see the information. Here's some information. It is in person because there's so much hands-on stuff. But we have a discounted rate if you are, the venue is a hotel conference room, so you would get a discount. Your district should be paying for it, obviously, so they would get a discount. We cater lunch every single day, so we provide you with the food. We provide shuttle service to and from the airport, so you don't have to rely on an Uber. You don't have to rent a car if you don't want to. There's lots of dining and entertainment within walking distance. So if this is something that's interesting to you, visit my website. You can contact me through the contact page there, or just look at the Math 2024 Institute. You'll see pictures from last year. You'll see a session agenda and all kind of really cool stuff. And I hope to see you there because I think that you can really jazz up your math class with some cool hands-on stuff, with some games, and just with some new instructional techniques that make math really interesting and fun to be a part of.